This playlist includes the idea on Lebesgue's measure. But since Lebesgue's measure is a measure, let's start with the formal definition of the measure function. We need this so that we could construct relationships with the available measures we're going to discuss throughout this playlist, including, and most importantly, the Lebesgue outer measure and the Lebesgue measure. This is how we define a measure function. A function, let's say mu, where it is script m is mapped into this interval 0 from positive infinity, which of course strictly says that we are only going to consider 0 and positive values, where your script m is already identified as a sigma algebra. Take note, we already discussed sigma algebra and algebra in the greater sense in the previous playlist. Is a measure if it satisfies the following. So here are the two conditions to need to be satisfied for us to say the certain function mu is a measure function. The first idea is mu of your empty set. Take note that if we talk about algebra or sigma algebra, it's actually a subset of a power set of a certain set, let's say x. That would mean empty set can be a part of an element of that said sigma algebra, which is in this case m. So the first one is the mu of whatever be that function of your empty set is equal to 0. That's the first condition. And the second condition is this: if we have a set of a sub I for all I integers, okay, is a disjoint collection of sets in our script m, then it would be having this relationship that mu, again, mu is what we're trying to say if it's a function or not, mu of the countable unions of a sub I, which says from 1 to infinity, must be equal to the summation of mu of a sub i's as I starts from 1 to infinity. When you say distinct collection sets of our sigma algebra m, that would mean that there are no common elements to all of those elements on our sigma algebra. These two considerations are very important for us to say that a certain function is a measure function. And of course, as mentioned, since this playlist talks about Lebesgue's measure, and later on I will be defining that as well, and since we're talking about being a measure, it should also satisfy these two conditions. Now, we are presenting this because it's part of our playlist, is that we're also going to illustrate some important measures, and hence they should satisfy these conditions, or if we talk about relationships or implications with those measures, these two conditions may be used since we are going to consider them measures as we look into the illustrations of some examples. We will have them on the next few videos. Thank you very much for watching.